I'll be discussing the problem counting bits. The problem statement says that given an integer n, return an array answer of length n plus 1 such that for each I be 0 less than or equal to I less than or equal to n. Answer of I is the number of ones in the binary representation of I. So the approach says that this problem teaches the dynamic programming using bits, and the pattern is we need to build answers from higher numbers from answers of smaller numbers. Intuition that we need to take for each number from 0 to n, count how many 1 bits it has in binary using DP to reuse previous results. Brute force for every number from 0 to n, we need to convert it to binary and count the ones and store the result in the array. The time complexity of this problem is big of n log n, space complexity is big of 1. The most optimized solution to this problem is the problem says to compute how many 1 bits appear in the binary form of every number from 0 to n. Instead of converting to binary separately, which is show, we observe a pattern. The count of ones in a number I equals the count of ones in I, shift 1, I divided by 2, last bit removed, plus the value of the last bit I and 1. This lets us build the result using the dynamic programming in big of n time, where each new result uses a previously computed answer, and then the final array answer of I stores the number of ones in each number's binary representation. The pattern will be observed as 1 plus dp of n minus offset, where the offset is going to be the most significant bit that we have reached so far. So the time complexity of this problem statement is big of n and space complexity is big of n. And then the problem actually teaches us 7 patterns. First one is the dp on array, where we need to reuse smaller indices. Second is I belongs to I slash 2, relationship right shift. Third is extract last bit using I and 1. Fourth is remove last bit using I shift 1. And use binary block structure powers of 2, big of n, update per index. Seventh is incremental computation instead of full recomputation. And there are 10 similar practice problems for the exact pattern, which I have also listed above.